Hello, everyone. Welcome back to your channel of probability and statistics. As promised, I'm going to go over RStudio and show you how you read files this time and how we are going to check, the t-test. We do the t-test. So I opened a new file here. It's untitled. Usually, what I prefer to do is to clean the environment every time I start a problem. And you say, but the environment is empty. It says that here. Yeah, but sometimes you are solving many problems and you are using the same variable name. So if I use X, for example, in one problem and I don't clear it and I use it again, I might get erroneous answers. So there is something that you can just memorize it. It says remove the list and list equals ls. Just that. So this line, even if I had a variable here, it will remove it. So we'll see that in a moment. Okay. Now I opened three files just to show you those. So here I have a file that has x and y values. Uh, 10 units for element Y, no, man meaning not available, and 19 for X. So X is 19, Y is 10, and we are going to run a t-test to see if there is a difference between the two. Okay? So T versus mu equals 0 versus not equal 0, a two-sided test. But first, I want to upload this in the memory. So I can create my own variable. I'm going to call it, for example, my data or my file or anything, okay? So I'm going to say my file equals read dot table, which is this one. When I read dot table, it means I'm reading a text file. It's not a CSV like the next problem, but this one is a text. So with the text, you use table. With the CSV, you use CSV. Okay? Okay. Let me close this and start it again because I want you to see something. You enter the file name exactly as it's written, and I changed the name. It was like an example that we worked in class, so it had numbers. So you enter it exactly as it's typed, case sensitive. So to sample means dot text. Okay, that's exactly how it's written. Then I would say, comma. Remember when we looked here, there is a header. I want to tell RStudio that the first line are the names of the columns. It's not, excuse me, it's not values. So you say header equals true. In fact, if you say true, it will understand, but you see header equals, and then I would say true, and it's case sensitive. I have to write it in uppercase. And that's it. So now I read the file. Let's run this line, for example. And it tells you here, my file has 18 observations of two variables. If you click on it, it will open it for you in a tabular form. Okay? And we had 18 values, of course, for X, but only 9. Remember, I said 19 and 10 because I didn't realize we had a header. But actually, this tells you exactly, how many in each or how many data do you have. So you have two variables that are the columns and 18 observations. Some of them are missing, but there are 18 in total for each one. Okay. So let's close that. Notice what happens if I run this line by itself. Control, enter, the environment becomes empty. So that's what I was telling you about. If I want to clear, because I was solving like three problems in this file. After I'm done with the first, I will retype rm list equals ls to clear the memory and then start. I can use the same variables again and they are clean, right? They don't have any value. Now, if I want to refer to a variable x, for example, not the only way, but the way I can use it now is to say my file $x. Okay, so if I run this, you see, I see the x values. They are printed out for me. But if I say just x, what would happen? Yeah, I got it again because I already did that. Let's start. Uh, okay, so the other way, in fact, that's probably the new version because here you have to say attach my file and then you can access the X and Y. But since they changed that, it's even better. So now I can run a t-test right away. There is nothing more I need to do. I can say t.test. It asks me for the variables. Now I have two. So instead, last time we said X, this time I say X and Y. If you look at the help for the t-test, let's enlarge that. You have to enter the alternative, and the alternative is either two-sided, less, or greater. So in this case, we want to see if there is a difference. So I would say alternative. Oops, I'm sorry, I have to. Alternative equals, and then between quotation marks, two-sided. Do you see after that it says paired, meaning is X and Y dependent? Pair t-test is what the one we did in the last session when we said new tires and old tires, and they are dependent on each other, and we subtracted. We call that the pair t-test because every number, first of all, if you see that we have more X than Y, so pair doesn't make sense, right? It's not paired. Even if I don't know, is this file giving me independent or dependent readings? Definitely independent. If they are dependent, you have to say before and after, or right and left, or model 1 and model 2. They have to have the same number of observations because you're going to subtract them from each other. And since these are not, then I know it's not paired. So paired is false. That's the default. So I'm not going to change that. Also, you see here, they say the variable being equal is false. And I want it to be false, so I'm not going to change that. If I want to run it as if to say the variance in X and Y is the same, I would make variable dot equal equals true. Okay, and finally, I want the confidence level. So I want to run at alpha 5%. So my confidence level equals 0.95. See how simple it is? I read the file and I'm going to run the test. You look here that T is negative 2.09, 17.9 degrees of freedom. Remember when I told you the degrees of freedom will never be an integer value? It's almost impossible, right? And the p-value is 0.0506, so barely failing to reject. Okay, so I cannot say that one is better than the other because the p-value is slightly higher than 0.05. In fact, it's almost equal to 0.05. If it were, I would reject, but if it's slightly higher, I would fail to reject. And this is really interesting because if I run this at 10 alpha equals 0.1, I would reject. Why? Because at 10%, meaning 5 on the right, 5 on the left, it would be narrower. So my t-calc would be, in fact, on the left, to the left of that. So you see, it's very critical. Even though I say they are the same, but I cannot give it, I give it with a grain of salt. I say the p-value is very close to 0.05. I was about to reject the null hypothesis. This is important. So you are not very confident like the problem we had before with the tires. We had T was like the p-value was 0.001. I have it in front of me. Okay. Also, because we failed to reject, it means the difference of zero should be in your confidence interval. When we did a 95% confidence interval, we went from negative zero point 0.9 to positive 0.001. You see, if that was negative, if both of them were negative, I would say I would reject. And that's when I told you they go hand in hand. And this one is very close to zero. If it were zero, I would say no, I didn't get a positive on one side, a negative on the other. So I would reject the null hypothesis that this guy is the mu equals zero. Okay, so that was an easy one. Let's look at the second example. The second example, I think this was like a force of the knee of a person. They got like how many they are? 13, 12 people. Okay. And they started to measure how powerful their muscles are when they flex their knee at an angle of 5 degrees versus 45 degrees. And so that's the same person, 5 and 45. So most likely they are dependent, right? If a person is strong, he would be stronger at 5 and 45 than a person who is weak. So that's why we can run the pair t-test here. So if I go back, but now I'm going to change the name of the file. It's force.csv. And here I'm going to write read CSV. And header is true. Now I'm going to run this test to see if the force at 5 is higher than 45, 45 is higher than 5. This is the 45, this is the 5. No, where is this is the one. Okay. This is the 5, this is the 45. So I'm going to check to see if mu equals 0 versus mu is greater than 0 because I'm going to do force 5 minus force 45, x minus y. So I'm going to say here two-sided, yes. No, it's one-sided, it's greater. And here the t-test is between force, the first one, oh, I keep forgetting, force 5, comma, force 45. And then I'm going to say paired equals true. And the confidence level is 0.95 as it is. That's it. So notice I have still my file in the data, but once I start reading, before reading even, it would be cleared by this line. Okay, so let's run it. Yes, you see now my file has 12 observations of two variables, force 5 and force 45. When you look at the output, you see my file, the pair t-test, the t-value is 7.4, extremely high. The p-value is almost zero, 6 over a million, 6.6 over a million. So, and the alternative hypothesis goes from 3.5 to infinity. The zero is not there. And that's why we reject the null hypothesis that force 5 and force 45 are the same and conclude that force 5 is higher. So the person is stronger when they flex their knee at 5 degrees versus 45 degrees, which makes sense. 0 degree is horizontal, so you return your leg to your back horizontally to the floor, and then you incline it 5 degrees versus 45. So at 45, it would be less strong. So here we did it. You see, only we changed the text versus to make it CSV. And we changed alternative to be greater instead of two-sided, and the pair to be true because that's now we are comparing the same number of observations, and we know they are dependent because they are for the same person, the same leg. Okay, the last one I wanted to go over is an example here that I already entered the data for you. So the data, we are not reading it, it's already there. Okay. And oh, by the way, here also, if you don't want to use force X and force Y, you can come here and say X equals my file $ force 5 and Y equals my file $45. And now I can write X and Y here. And I'm not going to I'm not going to delete to show you that we should get the same result. So I'm not going to remove or clean everything. Oops, force 45. Why did I say 45? Force. Oh my God. I thought that it worked. Okay. So it gives you the mean difference of 4.7 something, which is the same, 4.7083. Remember here we had a confidence going from 357 to infinity. 357 to infinity. It's the same 6.6 in a million. So you can change the names of the columns. It won't change them in the file, but you are change them inside your code. Okay. Let's clean this. Let me run this line, which I think it's already there. So here's the example. We have two lists, X and Y. They are the same size. So I wanted to show you, first of all, let's run this. So I have here, there are 16 data points. If you want to look at the values, again, you can click and open them. But suppose I want to check, remember I told you some statisticians would run an F test to check, to see if the variance is the same. Another way to do it also, after doing that, is to say, do you think I should, I don't know what X is, what Y is. Do you think I should run a pair test or a two-T test? Can we run a correlation between X and Y? And if it's close to 0, I run a two-T test. If it's close to 1, I would run a pair T test. Let's try to see what get. The correlation is 0.84. If you learn, if you did that in your high school, or if you are taking statistics in high school now, you know that this is a high correlation. So I probably should run this. Let me run it two times, okay? We are going to run it two times. We are going to say t dot test x and y. Let's say mu equals 0, alternative equals two dot sided, and notice that we always going to assume that the variances are not equal. So I'm just going to do confidence level is 0.95. And then I'm going to copy this and paste it here, but I'm going to go somewhere and say um, paired equals true. So I run it once as a regular 2T test and one as a pair T, pair test, okay? Meaning independent on the first, dependent on the second. We guess that the dependent will have shorter or smaller confidence interval because these are highly correlated. And also it can detect a difference between the list. I didn't run it, so I don't know what I will get. Okay, so now we ran it. Let's look at when we did the Welsh two-sample t-test, meaning it's the test that is not paired. They are just independent. We get a p-value of 0.34. It means that we are not going to reject the claim that they are the same. They may be also the same, but I should expect p-value to be smaller in the case of paired because it can detect smaller differences. Because now I made the correlation here, the expected value of xy would be, I would subtract twice the covariance, right? Twice the covariance. And notice that the 95% confidence interval go from negative 3.6 to 10. Now, what is it here? I reject the claim that they are equal. You see the p-value is 0.03, less than 0.05. Here it was 0.34. It couldn't detect that. Do you see how powerful now the pair t-test is? But you cannot always use it. If you use it while the two samples are independent, oh my God, it would be less powerful. Why? Because you are losing degrees of freedom without decreasing the variance. You see the degrees of freedom here are 29.8. Here they are only 15 because you have 16 points and 16 data points, right? So never use one if you are not given. So if they give me two samples and the problem doesn't tell me, usually in at this level they will tell you these are, use the pair t-test or use that. But if they don't tell you that, it's the best way to do it is to run a correlation. If this correlation turns out to be like zero point 0.2 or zero point 0.3, I would say, nah, that's not good enough. I'm going to lose almost half of my degrees of freedom, but I'm not going to gain much decreasing the error, which is the standard error of the means. So in which case, I'm not going to use the pair t-test. But in this case, we got 0.84, I believe it was, right? Correlation was 0.84. That's extremely high, very high, okay? So in this case, we use the pair t-test. I hope this was clear enough. If you have any questions, please let me know in the comments, and I will get back to you as soon as I can. Next time, we will start doing confidence interval or test of hypotheses of variances. Okay, and that's it for today. Thank you very much for your time. Hope to see you soon. Bye. Oops, I'm sorry. I should be here.